Okay, this is an example of a B tree of order n equal 1. So we have a rule about B trees from the notes that a root will have 1 to n keys. So that means 1 to 2n keys. So that's going to be 1 to 2 keys for this particular example. And all the children will have n to 2n keys, which for the case of 1 is still going to be 1 to 2 keys. So the roots have 1 to 2 keys and the children have 1 to 2 keys. Just for this example of n equal 1, which is not a realistic example. It's just a simplest tree that we can make for academic purposes to learn this thing. So we're going to do an insertion sequence of 5, 9, 7, 4, 3, 2, 6, 1, 10, 11. All right, so we insert the 5 first, and we have a root. We create a root, and we put the 5 there, and we're done. So we insert the 9. So the 5 is here. We start scanning from left to right, and 9 is bigger than 5, so we put him here, and we're done. So now we insert the 7. So we start scanning this guy, and 7's bigger than 5, and 7 is less than 9. So we scoot the 9 down and put the 7 here. Okay, now this thing is overflowed, right? It's more than 2 keys in this root, so it's going to split, and the 7 will kind of pop out of this thing. So we're going to do a split, and the new node, the new root, will have the 7 in it, and the 5 and the 9 will break into 2 new nodes, and the 5 will go here and the 9 will go here. And then the pointers, which are drawn, the pointers are just another array. So we draw the pointers coming out of these lines here, but they're just another array in the node. So just checking here, is it okay? So all of the key values in this leaf are less than 7. That's good. All of the key values in this leaf are bigger than 9. So that's good. So let's do an insert 4. So we always start at the root, and we start at the root and we follow all the way down to some leaf, because for a B tree, all of the insertions are done at the leaves, okay? At the leaves. So you start here at the root. 4 is less than 7, so we follow this pointer. This is a leaf, so we're going to put the 4 in there somewhere. And it's less than 5, so we got to scoot the 5 down. So it's going to look like this. The 7 stays there, the 5 gets scooted down, and the 4 goes there. And this node is here. The arrow is pointing down. Just point to the whole node. Okay, so it's not really important where you draw this arrowhead. You can put it in the middle if you want, but leaving, they should leave from these lines here, because they're associated with their matching key. Okay, so it's time for insert 3 now. So we start here. 3 is less than 7, so we're going to follow this link. Okay, this is a leaf, so 3 is going to go in here somewhere. The 3 is less than the 4, so we got to scoot all these dudes down. So the root stays the same. This 4 and 5, the 4 gets scooted down and the 5 gets scooted down, right? And the 9 stays the same. So this is a temporary situation here with this overflow, but you need to resolve it, so you need to do a split. So just an implementation detail, you do need to keep one more extra spot, because this will, be 1 too big for a little bit before you do a split. So what's going to happen is the 4 is going to pop up, and this leaf will split into 2 pieces. So this 4 is going to go up into its parent, and it has to be in sorted order. So that means the 7's got to scoot down, and the 4 goes there in this root. So there's going to be 3 pointers down. Everything in here is going to be less than 4, so that's going to be just the 3, because this leaf is going to split into 2 leaves. Here's one, and here's the other one. Everything following this link, everything in this leaf is going to be bigger than 4 and less than 7. That's 5. And everything in this leaf is going to be bigger than 7. That's the 9 the leaf that contains just the 9. That's that. It's time for an insert 2. So we start at the root, following down to some leaf, because all the insertions are done at the leaves, at the very bottom of the tree. But you start at the top. 2 is less than 4, so you follow this link. 2 is less than 3, and this is a leaf, so we're going to put it there, so we got to scoot the 3 down. So I'm going to, I don't want to redraw this. I'll redraw it. So the 4 and the 7 are there. I don't want to redraw, it's hard. So the 2 goes here and the 3 scoots down. All right, and the rest of the tree is the same. The 5 is there, the 9 is here. All right, now it's time to, I'm going to squeeze in the, so it's time to insert 2. I'm going to squeeze in the 6. So you start here, 6 is bigger than 4, less than 7, so we follow this link. We're at a leaf, so the 6 will go here, it goes in here. Okay, then let's do insert 1. So we start at the root, 1 is less than 4, so we follow this link. We get to this node, which is this one, and 1 is less than 2, so we got to scoot these guys down. So 1 goes there and 2 goes there, and 3 kind of falls out, and the rest of the tree is the same. So this is a temporary situation where we have an overflow. We have to resolve it with a split. So the 2 will pop up, and this thing will split. So the 2 is going to go up to the up to its parent. So remember, these have to be in sorted order. So the 2 is going to go before the 4, and the 4 and the 7 are going to scoot down. So 7's overflowing now temporarily. This leaf is going to split in half, form 2 leaves, with the 1 in this guy and the 3 in this guy. So everything in this node is less than 2. Everything in this node is between 2 and 4. Oops. Sorry about that. Everything in this leaf is between 2 and 4, so we draw the link down that way. Everything in this node is between 4 and 7, right? And then there's an extra pointer that you have to allow in here for a little bit before we resolve that. And everything in this node is bigger than 7. So the root has overflowed now. So it's going to split. So, first the leaf overflowed, the 2 went up. We resolve that at the leaf level, and then we backtrack and fix the problem that we made up here by the 2 coming up. So the 4 is going to go up, and there's going to be another split. So there's going to be a new root formed, and the 4 will be in that. This 4 pops up to a new root, and this former root splits in half, and the 2 goes here and the 7 goes here, right? And this thing points down to guys less than 4, and this thing points down to guys bigger than 4. Okay, then these leaves just fall in here. There's going to be 4 of them. This one has the 9, this one has the 5 and the 6, this one has the 3 in it, and this one has the 1 in it. And then you just hook up the pointers from the next level up. So this points down to guys bigger than 2. This thing points down to things smaller than 7. This thing points down to things bigger than 7. And yeah, you could continue in that. What's next? Did I do 1? yeah, 1 there, right? This is insert 1, which caused a double split. So now it's time to do 10 and 11. So 10 would, 10 would go, 10 would go here, right? And then 11 would go here, and then this guy would split, and the 10 would go up here. And if you put, and this leaf would split in half. Eventually this guy would split. I mean, we could make that happen, I guess. So let's put in, let me draw a line here. It's getting kind of messy. So put in this, let me redraw this. You know what? I'm just gonna do it here, 10. Now, on your homework, you really should redraw these at every state. I don't want to do that now because I don't want to take a bunch of time watching me do that. And it actually detracts from, if I go too slow, I think that's bad. But anyway, put the 10 in here, then an 11. So the 11 goes here. The 10 would split. It would go here, right? This would become two children. I could squeeze it in here and make a mess. But the 9 would be there, and the 11 would be there, and this would point to to that, and this would point to that. And then let's say we did if we did a 12 and a 13, the 12 would go here, the 13 would go here. This would split. It would go up to here. This would split, go up to here. And you keep going, eventually this guy would split. Yeah, I think you can do this fine. Should be no worries. Make it pretty, unlike what I just did right here. Okay, thank you.